Okay, so we're going to look at our sine graph. So what we're going to do is we are going to take our y equals sine of x. This is chapter 10.1, the sine and the cosine graph, which I've showed you 8,000 videos and you should be okay with, but just to make sure you're good. When we do graphs for the sine and cosine, what we do is we usually label our period across the bottom. That's how long it takes before the curve repeats itself. And then our numbers on the top, which usually go from 1 to -1 unless we have a number out in front, which will change things. That's called the amplitude. But let's do a simple one right now. So if we set up a little, if we look at the y, before we set up our graph, look at your y equals sine of x. Equations are usually of the form y equals a sine b x. If ours is y equals the sine of x, we can tell here that there isn't anything in front of the sine, so we know it is therefore understood to be a 1. There isn't anything here in front of the x, so b is also understood to be a 1. We need this information because of two things. First of all, the a tells us how high the graph is going to be stretched. If it's a 1, it just means we follow our regular curve. If it would be a 2, you would stretch whatever normal point you would have on the sine curve, you would stretch it up. And we'll do one of those in a minute. Now, b equals 1 is important because you need to figure out the period where it repeats itself. How long does it take to repeat itself? And that's always equal to 2 pi over b. So here we have 2 pi over 1 because b equals 1. So we get the period is 2 pi. What that means is we're going to start here at 0 and we're going to go to 2 pi. That's when the graph will repeat itself. To figure out the rest of the points in between, you need to break it into quarters. Okay, so halfway through would be pi. And then halfway between 0 and pi would be pi over 2. And halfway between pi and 2 pi would be 3 pi over 2. That's your typical graph right there for the sine of x. Okay, it's going to look just like this. Now you can use the sheets that I gave you that figured everything out, or you can use your calculator. Let's start at 0. If we figure out y equals the sine of 0, what is the answer to that? Sine of 0 equals 0. So at 0, 0, we have our first point for the sine curve. Then we try y equals the sine of pi over 2. What is the sine of pi over 2, or 90 degrees? It equals 1. So pi over 2 equals 1. Then we do y equals the sine of pi. Notice we're just taking each of these values and putting them in here. Sine of pi is equal to 0. So we're back to 0. Now let's do y equals sine of 3 pi over 2. And that's going to equal -1. So we go down to -1. And then lastly, we do y equals the sine of 2 pi, and we get 0. So when you draw your sine curve, it's going to start at 0 and go up, then down, then up. Now it continues on, but this is as long as this is the pattern that it will take. So the next group of the if we kept going, it would go up and then down and then up again. Like this, okay, and so on. But the period here, before it repeats itself, is 0 to 2 pi. Now, you kind of have to memorize this graph, because until you know this graph, it's hard to get the other graphs. For example, this is what I want you to remember for the sine of x. The graph of the sine of x. It starts at 0, 0. Okay, it always, when it's at 0, it starts at 0. That's one thing to remember. Where else does it hit 0? At pi and 2 pi. So if you can remember that it's a 0 at 0 pi and 2 pi, you're good. And then between 0 and pi, it goes up to 1, and between pi and 2 pi, it goes down to -1. You have to kind of get that basic graph in your head so that we can do the next graph. So let me show you how the graph might change. Okay, so let's say we have y equals 2 sine of x. Okay. Remember, we look at y equals a sine bx. A here equals 2 and b equals 1. You always take b to figure out your period, or how long before it repeats itself. So the period is always equal to 2 pi over b. If we substitute a 1 in for b, we get 2 pi. So that's perfect because we can do our graph the way we always do it, from 0 to 2 pi, because it ends at 2 pi. And we already know how this goes. Pi over 2, and 3 pi over 2. And here we have our 1 and our -1. And this time we're going to go down to -2 and 2, because what you're going to see is that this a is going to change things. Now remember what I told you. When you do the sine, graph or the sine curve, you had a 0 at 0, pi, and 2 pi. Remember that? And then in between we had 1 and -1. So since our 0 is at these 3 values, we again keep our zeros at those 3 values, 0 pi and 2 pi. It's just like the regular sine curve. Now where a comes into play is, remember that pi over 2 for the regular graph was, remember how we did it, the sine of pi over 2, sine of pi over 2 is equal to 1. But this time, because a is 2, you take 1 times the 2. This is our a, and you get 2. So you don't go up to 1, you go up to 2. Same thing for 3 pi over 2. Remember when we took the sine of 3 pi over 2, we got -1. But because a is 2, this is a, we get -2. So between it goes down to -2. So notice the difference in the graph here. It goes up to 2, down to -2, and up again. Remember, it keeps going. That means it's sinusoidal. That keeps going on and on. But this is the length before it repeats itself, the period. Notice how it differs from the other graph, the previous one. The previous graph, we had it from 1 to -1. And then on this one, the difference is it goes from 2 to -2, but the zeros stay the same. So that's the first thing you got to get about a. Once you get that down, you're going to be pretty good. Okay, we'll start by practicing those. Now, let's try another one. Okay, let's try y equals 1/2 sine of x. Now you try to do that and see what you come up with. Again, a is going to equal 1/2 and b equals 1 because there's nothing in front here. So that's our b and this is our a. So again, you're gonna do the same values that you always do. We're not sure how far we're going up or down, so we'll do 1 and -1. And because b is 1, our period equals 2 pi over b, which equals 2 pi. We start at 0, we go to 2 pi. This is the same graph every time, unless the period changes. It will change when b doesn't equal 1, which we'll do in a little bit. This is pi over 2, and this is 3 pi over 2. So we go to start our graph. See if you can come up with what it is. Remember what I told you. Start at, where are my zeros in the regular sine curve? If we go back to our zeros in the regular sine curve, they were at 0, pi, and 2 pi. So let's put a 0 on 0, pi, and 2 pi, because those aren't going to change, because 0 times a, notice a is 1/2 here, 0 times 1/2 is still 0. That's why these values stay 0. Now in our regular graph, okay, in our regular sine graph, if we go back, what was pi over 2? Pi over 2 was 1. So let's go to our current graph. We have the sine of pi over 2 but a equals 1/2, so we have to take 1 times 1/2, which is 1/2. So now instead of going up to 1, we're going to go to 1/2 for pi over 2. And you guessed it, negative 1/2 for 3 pi over 2. So do you see that a now has stretched less than the original graph? Let's look again. Here was the original graph, y equals sine of x. A was 1. Then we looked at the next graph where a was 2. See how it's higher? That's called the amplitude. The amplitude is higher. And then we looked at the next one where a is 1/2, and it's lower than the other two. The amplitude is lower, less of a stretch up and down. So as a increases, the graph gets stretched higher. Okay, let's start with that, and hopefully you'll figure out what we're doing here. Okay.